and we're going to cover some very important information about the biggest change in 70 years to traditional facades and how they're attached onto steel framed buildings. So we're not talking about concrete frame buildings, but we're talking specifically about steel frame buildings. And this is something that has been just developed within the past year. So here we see some of the traditional support for a masonry facade, and it includes a brick ledge that has been designed to be field welded onto the steel bent plate pour stop. The limitation that's associated with this for brick support is that it's got a high degree of field welding, and that's high labor, cost, and time associated with the project. More often you might see a detail like this, which includes a hanger to a brick ledge. And so again, we see that it still requires field welding onto the steel pour stop, which requires a lot of time and cost associated with that field welding. Traditional precast concrete support, it looks something like this, to where we have a steel beam and then we've got that steel pour stop, but we have to have an embed usually in the top of the slab, and that embed with anchors needs to develop the loads seen from that precast. And usually this involves a setback or a real estate setback so that the studs start out of the way of these anchor systems. So there's a loss of real estate, and there is the cost of the embed associated with this for a traditional precast support. For lighter weight facades, we might see something like this that has steel studs, and we have some type of a clip angle supporting that. We might have an insulation system out to the side. And traditionally, this will be attached either by welding to the bent plate or by shooting it with these pin-type anchor fasteners through the bent plate. Now, there are some questions associated with the longevity of these types of pin connections into the steel plate, because if it has concrete behind it, they may be rejected. And so there's a lot of questions associated with this from structural engineers. And so it might be more of a field welded type of connection that we might see. Traditional curtain wall support for the past 70 years or so has been something like this, where we have the bent plate on the beam and it is welded. A typical tab or a anchor connection is welded to that bent plate. Every once in a while, we see curtain wall that needs to have some type of an embed put into it associated with steel framing design. The problems with this are that there's limited amount of room in the lightweight concrete to be able to develop the loads back into the concrete edge for the curtain wall loads. And so this becomes very difficult. We can kind of see a picture here over to the side that shows that in one instance, you can kind of see that bent plate pour stop that's on the outside. It had to be cut away, and they had to enter in a box. And you can kind of see all of the reinforcing, the studs down beneath it, and the reinforcing that is added into it. Very costly. And it's rare in the area of steel frame buildings because of the cost and the nature of being able to develop these loads back into the lightweight concrete slab. So for the past 70 years, we have seen the same deal where we're working around this bent plate. In this instance, this is not 70 years ago, but it's in the 1970s. It's in Kansas City, and it includes a bent plate pour stop, and we have some type of a developed anchor back into the concrete, and you can kind of see the clips for the curtain wall support, and they're welded off to the underside of that bent plate pour stop. Here's another one that's in Kansas City, Kansas. It's a headquarters for the city, and this is precast, and so we can kind of see that precast anchor that sits on top of it, and it's welded off to the bent plate pour stop, and that bent plate pour stop has some type of an anchor system to try to develop the loads back into the concrete. Probably back then, they weren't using lightweight concrete. They were probably using a heavier weight concrete to develop the loads. The problem of the past 70 years has been that we're working connections around this steel bent plate pour stop that has been in place. And so somehow we have to get the loads past that bent plate or through the bent plate or around the bent plate to be able to get it into the building structure. And that's kind of where this idea has come from and generated. It's a continuous pour stop and continuous anchor system attached directly onto the structural steel so that it performs two functions at one time. So there's a lot of different advantages associated with this, but the idea came about by asking glazing contractors, what is your number one problem out in the field that you suffer? And to almost a T, they'd come back and they'd say, welding these anchor plates, these anchor clips onto the side of the bent plate pour stop. And so that's kind of developed into a continuous pour stop and anchor system. So here's some of the advantage of this new type of pour stop and anchor system. It is better structurally. It offers a better load path into the building structural system. It's concentric versus eccentric that's associated with the typical traditional bent plate. So in other words, there's an eccentricity for welding this onto the side of the bent plate that wants to bend that bent plate pour stop outward. That's avoided in this concentric connection associated with J-edge anchor system, making it structurally better. In fact, the better load path equals about 150% increase in load capacity structurally. Now, not only that, but we have a stronger steel. So whenever these are extruded, they're extruded out of a large billet steel, and it comes out at a 60 KSI or better yield strength versus a 36 KSI yield strength for the traditional bent plate pour stop. That is about a 60% overall increase. And so whenever you add those two together, we're over 200% increase in structural capacity for carrying facade loads over the traditional bent plate pour stop. So it's better structurally. Some of the other system advantages are it offers an adjustable bolted connection that avoids costly field welding, and it also reduces anchor installation mistakes. I talked to a glazing contractor a while back that said that almost every single one of their clip angles got installed in a wrong position, and they had to undo and re-weld, essentially cut away these clips and re-weld them onto the bent plate pour stop. Those types of mistakes are avoided with this adjustable system that's continuous along the exterior of the building. In addition to that, this new system reduces the overall construction schedule. We interviewed many glazing contractors, and they are estimating about 15 minutes per clip angle, and a mullion has two of these clip angles, one on each side of the mullion. And so you can see that 30 minutes for construction of each mullion around the edge of your facade system to the bent plate pour stop. So this bolted system greatly reduces that install time down to where you can finish up several of these in 30 minutes. In fact, I think that there was one glazing contractor that estimates, and we've got a video of them up on the website, about 20 of these can be installed in the time that it takes to install one of these. So the bolting of this connection speeds the time of facade enclosure. Another system advantage is it's a true straight edge of slab versus the wavy bent plate that we have complaints from many glazing contractors about. This plate, whenever it gets bent in the shop, is actually not to a very high tolerance. It's got a lot of wave in and out of the building, and so there's a lot of accommodations that glazing contractors have to make adjustments for in this wavy bend plate. Not so with J-edge anchor system. It's virtually very straight, and it's welded onto the structural steel. So it's high tolerance. Another advantage that we found has been associated with the safety railing during construction. So I'm sure that all of you at Ryan would be interested in this. This is a typical construction safety railing that we might see for the traditional bent plate, where it gets installed and welded off, and an angle riser gets welded off to the inside of the bent plate pour stop. And so what happens to those after we have the concrete in place? Essentially, it's wasted. And so they have to cut that off at the slab level. And so it's wasted material. In addition to that, at the slab level where you cut this off at, it creates a nice intrusion into the slab where cracks may originate from. So we've developed an accommodation for a reusable safety railing that's associated with the J-edge anchor system. And so it's a bolted system with a keyed bearing lock and an adapter associated with it. And so it actually looks like this. It looks like this on the construction of the outside of the building. You can kind of see those bent back into the plane of the interior of the building. You can see the adapter there. The safety railing stays in place while the facade is installed. And that's the reason for the bend, because you can actually install the facade over that. Now you can kind of see that J-edge anchor system there, that line that goes through, that's where the actual toggle bolts fit into. Here's another view of the inside of it after we get curtain wall installed over it, and this safety railing stays in place and can be removed at a later date really easy. There's just a bolted system on the sides of this, and so it can be removed by hand. Another advantage that we see is the ease of temporary construction and closure. In other words, using that same adapter system and some post with some type of a temporary fabric to enclose, we can fastly enclose the building structure to control the environment on the inside. Another system advantage would be in handrail. And so this would be for exterior and interior use for mounting handrail. It's a very quick and easy system to be able to mount that handrail. One of the additional benefits may be a thermal break, increasing the thermal break that you have and the lack of conductance from the outer parts of the curtain wall into the interior of the building. Another possible benefit would be this. Many systems that are in curtain wall are starting to go to a cassette system. And what I mean by that is that they have a toggle that will actually allow the replacement of SSG glass. And so this toggle kind of toggles in place and it holds the glazing in a pocket like this. Whenever this cassette system with the toggles are combined with the J-edge anchor system, this may allow for possible reuse of the systems to go from something like this for a facade exterior to something like this in the future. And so there may be a lot of reuse that we get out of future renovations of exterior facades for this type of system with J-edge anchor system. It also improves the performance and the attachment of other systems, other facade systems. So in the case of precast, we're looking at something like this on the front side of the slab edge instead of what we had before with a traditional precast support where we lost real estate. And so this one requires a setback to the real estate, the stud construction, and an embed with development of the loads back into the slab. More likely, we might see something like this, and it's an underhung connection for precast off of the J-edge anchor system. And so again, you lose the real estate that you would before for precast. For masonry, we might see something like this associated with the bolted system to support a ledge anchor. Or probably more so, we might see a hanger system that is bolted off of J-edge anchor system with a ledge supported on the outboard. For cold form steel framing and lightweight facades supported by it, we were talking typically about the construction of those pin fasteners shot into the bent plate pour stop, or field welding associated with the tabs up at the bent plate. And now we can talk about a bolted system, or even if they want to shoot fasteners in place, we have some air in the back of it that won't reject the pins or the screws. And so this you could actually attach with screws or bolts. We have some options that have been developed on previous projects associated with setbacks, where we have the beam that is set back from the exterior plane of the building. And so this would be frame mounts associated with that, and optional anchor bars for the J-edge anchor system, and an optional extension associated with any slab depth to accommodate any slab depth for lightweight concrete slabs. Here's the biggest advantage associated with J-edge anchor system. Is the cost better? The cost is better and has proven itself out. The increased cost of the part, right now there is an increased cost of the part, is typically less than the deducts that you would associate with all of the field welding of various facades in lieu of bolting. Here's a real example of a medium-sized office building, 7 floors, Kansas City, Missouri. So the increase in the cost for the J-edge versus the bent plate that was already planned was $92,000. The deducts that were seen associated with the curtain wall installation, so that they did not have to weld onto the sides of the bent plate, was $200,000. So that's a savings of $108,000 associated with that 7-story building. Now, this doesn't include savings for reusable safety railings, the faster construction schedule, or the value of potentially opening an office 1 month earlier. We've done lots and lots of engineering analysis associated with this from development up till now, and we actually get into analysis of different configurations when people want to see if it applies to their building. We're available to do that. We've actually done a lot of testing associated with this, and you can kind of see the testing that we've done there. And from that testing and from the design calculations, we've actually been able to produce some engineering load tables, interaction load tables, where we can see where the loads are for the facade attachment, and we can see that we're, in this case, well below the allowable design load for J-edge anchor system. Our website has a lot of information available associated with the sample calculations that we've done, where we've compared a bent plate pour stop with the J-edge anchor system. It includes testing documents that you saw briefly, we just briefly touched on, but it's very detailed testing documents. It includes AutoCAD files, Revit files, RISA files. And it also includes a gallery of videos where we go into a lot of different subjects and a lot of different questions associated with J-edge anchor system. So to summarize, we've covered a lot of things associated with delegated structural design. We covered the building structural movement issue that is typically overlooked or often overlooked in manufactured type systems. And we've also covered one of the great changes, I believe, in the last 70 years associated with facade connection. So this facade connection has better structural capacity. It has advantages for construction. It has a faster construction schedule, and it saves in construction cost. We have early on review testimonials that are great. J.E. Dunn, McCown, Gordon, Turner, and also we have it under construction in several different projects, with the most notable, the Microsoft campus headquarters up in Redmond, Washington. And so that's currently in progress. And we have others that are actually in the design stages around the Kansas City and Midwest region. So what are your questions and what are your thoughts?
I think if we just unmute and then our video, we can have a conversation right here. So if you have a question, open up or unmute yourself and ask your question. Anybody brave enough to give comments?
Is there a story limitation to this system? Like, could it be used on a 25-story building?
Yeah, so that's a great question. There are no story limitations associated with this. It can be used on very high-rise type of buildings associated with steel framing. Yeah.
Thank you.
Other questions? Okay, well, if you do have questions, you've got Stuart's email address, and we'll send a follow-up email just to make sure you have that. If you do have some projects that this could be presented on, what's worked well in the past is having a presentation that's more of a deep dive on the engineering to either the general contractors, the engineer's record, the architects, whoever. And then Stuart, what are your final comments?
Well, I wanted to just be prepared, and so I was actually prepared with another couple slides just in case there was a question asked about seismic loads. And so we have been asked about that in the past, and so ultimately for seismic categories A and B, we don't really need to consider the seismic loads associated with the facade attachment, but whenever it's seismic categories C through F, we can actually design a slip critical steel connection associated with this. And this is different than the typical embeds that we would see. Typical embeds are governed seismically by ACI 318 and that design method that's associated with that. Not so for J-Edge. This actually runs back to the steel manual and the steel code associated with steel connections. And so we're able to design a slip critical connection. So you can kind of see on these typical embeds, there's no fang surface associated with gaining enough friction for the slip critical connections that would be needed for resisting seismic loads. But in J-Edge, we've got great surfaces there. In addition to that, these typical embeds are made of ductile type metal, whereas the J-Edge anchor system is made of a high strength metal and so can be used for those slip critical type of connections associated with seismic loads. So any other questions beyond that? Well, I really appreciate the opportunity to be able to present to you today. As I indicated before, we do lots and lots of glazing systems design associated with delegated design, and we also get on the front end as well. So if you guys are ever in need of having some curtain wall that you need consulting on, or some glazing that is high span with glass fins, we get into that. We get into glass flooring design and glass canopy design. So please feel free to use us as a resource. Really appreciate, again, the opportunity to be able to present to you today. Thank you so much.
Thanks, Stuart.
Thank you.
Thank you.